nice little rectangles because we can do algebra and get what those rectangles are. All right, now moving along here, let's go take a look at the next page. So I think we're done with that one, but if you want to take a look at these between 55 and 65, so we have a range here of that looks like between 55. Remembering compound inequalities are always written with the small number on the left-hand side and then the big number on the right-hand side, and you always use less than symbols. That is the correct way to write a compound inequality, and that's between two things. So we have between those two values. Well, the distance between 55 and 65, that is only 10, right? So this is 10/20ths. That's the probability, or the probability there, right? So the length times the width. So the width being 1/20th and the length being 10 here. So we cancel out here and we see that this is 1/2. So that's the probability of F. And then if we want to take a look at what's the probability that it will take the truck at most 52 minutes. So the probability at most, so that's less than or equal to 52, and remember with a continuous distribution and the uniform is continuous, we don't care if it's equal to or not, it's not going to change my probability, but that's the correct notation. And so I have the probability times the width of the interval, and less than 52, this would be 52 minus 50, and so that would be 2, and so now this would be 1/10, and that would be my probability. Now remember that I can use common fractions or decimals or percentages as probability, and I've left all of these as fractions, and that's quite fine. Okay, the next thing that we want to do is we want to actually do some normal probabilities. So the normal distribution is just this curve that is defined by this function here, and when we put mean in for 0, we're going to get the standard and standard deviation in for 1. We're just going to get this nice little function here, and this is the one that I was describing before, and this is what we get for this standard normal curve, this bell-shaped curve. The middle is at 0, the inflection point is at -1, and over here at +1, and that's what forms this. And these come in, approach, never cross the x-axis, approach, never cross, never touch the x-axis, asymptotic behavior. So we don't really care about this distribution. In order to get probabilities from that distribution, we have to have some pretty good calculus skills and analytical skills as well. So we let tables do the work for us, or our calculators. So I'm going to work on just taking a look at using a table first, and then I have a little bit of calculator video in the playlist on this. So all tables are set up to be read as cumulative from the left, or most tables are, I should say. That's the most common type. So I'm going to go over and I'm going to show us a standard normal table. Now the standard normal tables, they're both positive ones and negative ones, and the ones that I always give my students are the negatives. And I could give them both, but that wastes a lot of paper, and so I just give the negative z-tables. So here's your standard normal curve, and this is any z-score, and z-scores are going to be numbers typically between 0 and 3.5-ish, and they're going to show from that point down to -infinity, essentially what the area under the curve is. And that's the probability that we're looking at, because area under the curve in any continuous random or continuous probability distribution is going to be the area under the curve. So we can find the areas under the curve in this negative z table by looking at the ones in the tenths place over here on the left column, and up here on the right, or on the top row, we're going to see the hundredths place, the tenths and the hundredths place. So let's say, for instance, I wanted to find the probability for -3.02. So here's -3.02, so this would be a -3.02, and I'm finding the area to the left of that. In other words, I'm finding the probability that z is less than or equal to 3.02. So I'd be finding this right here, and I'd come over here until I got to 3.02. And that number right there is the probability under the curve. So let me take this z-table and just slide it down a little bit more. And then right over here, what that looks like, the probability that a z is less than a negative 3.02, that is equal to 0.0013. Now you remember the empirical rule, right? Well, the empirical rule here is what this is based upon these probabilities that we're learning right now. And the probabilities that you would expect to see for being outside of the range of 3 standard deviations. Remember, that was really super tiny, right? So the probability of being outside 3 standard deviations was the complement of 99.7. So 99.7, 1 minus 0.997, that would give us 0.003. And then if I divide this by 2, because that's in both tails, right, from the empirical rule, then this would give us approximately 0.0015. And this z-value, negative 3.02, is even further out. So if this is 3, right, 0.302 is out here. So the area under the curve, I would expect to be less than this approximate value of 0.0015. So this area right under here, according to the normal distribution, the standard normal distribution is 0.0013. And that's how you find normal probabilities. Now let's go ahead and go to the some problems that you can try on your own. So what we're going to do is we're going to, first of all, look up these straight lookups, okay? So what I've done here is I've shown you what would you do to look things up in the table, just straight lookups. The probability of x being less than an x. If you have a negative value or a negative value, then you're just looking it up in the table. And then if you have it being greater than an x, well, you're going to have to find out the area in the tail, the same over here, and you're going to have to subtract it from 1, the area underneath the entire curve. And then if you have the probability of being between two values, the small one on the left and the big one on the right, and they're both negative, you're going to take this probability of being less than the big one and minus from that the probability of being less than the smaller one. So let's take a look at these 3 examples right here, and then we'll move forward from there. So our probability of a z, because it says it's a standard normal, right? So that's a z, being less than a negative 1. So the probability of being less than negative 1, I suggest that you draw a little picture of this, and I will request of my students that they do that. Here's my 0 in the middle, and then here's my negative 1 over here. And so what I'm trying to find is this area right in here. So I will go to my z-table, and I'm going to look up negative 1.00. So this z-table that I've shown here, that would be down a little bit further. So I'll go over here, negative 1.00. So this is my value right there. So this is 0.1587. And that's the probability of being less than 1. So this area here is 0.1587. Okay, now let's take a look at the next one. So my next problem says, what's the probability of being less than 2.78 in a standard normal distribution? So now this one, z being less than 2.78, well, this one here, let's draw a picture of that. Here's my mean at 0, right in the middle. 2.78 is over here, isn't it? It's a positive number, so it's on the right side of 0. So if I'm on the right side of 0 and I'm going less than this, well, I can't find this value in the negative z table. There is a positive z table, but again, I don't give my students the luxury of having the positive because it wastes paper. So what I do is I'm going to actually look up the tail area using the idea of symmetry, because remember, the standard normal curve or a normal curve is symmetric. So if this area over here, it's the same as being greater than a 1.08 over here. So this here being greater than 2.78 is the same as being less than negative 2.87. So I'm going to look that up in my table. I'm going to say, well, what is the probability of a z being less than negative 2.78? Because that probability is the same as this probability right there. So here I go to my table to look it up, and negative 2.78, so negative 2.7, there's 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8. So this is my value right here. So that probability over there in that tail is 0.00 and 27. Again, a fairly small probability, right? It's getting close to 3. So if this in this tail here is 0.0027, well, that's over here that I want to find, that's the complement of it. So this is going to be 1 minus the probability that z for some reason my pen is not working correctly. Find my cursor. Okay. All right. That's interesting. I'm still not getting anything here. So I'm going to do 1 minus this probability down here of a negative 2.78. So my negative 2.78 here, my z is being less than a negative 2.78, and I can put it in that way, or I could even say greater than a positive 2.78. It doesn't really matter. This is going to be 1 minus 0.0027. Now you can put that in your calculator if you need to, or you can just do the subtraction. So I always kind of think of this as I need to make 9s for all of these, and then this one will make 10. So 9 plus 0, 9 plus 0, 7 plus 2, those all make 9s, and then I need 3 plus 7 to make a 10, because the last one has to make 10. Anyway, that's my crazy way of thinking about that to get that probability. And that probably made no sense to you whatsoever. If it didn't, just say 1 minus 0.0027. All right, so that's our next probability. Now let's go to this one here, find the probability of being less than positive 487 in the standard normal distribution. Now this one is in here because this is a little